Good afternoon, everyone, and thank you for joining us today for the QBCC Are You Ready for Storm Season webinar. I would like to begin by acknowledging the traditional custodians of the land on which we gather today and pay my respects to their elders past and present and emerging. I also extend that respect to Aboriginal and Torres Strait Islander peoples that may be here with us today. Welcome to the QBCC Tradie Tour. My name is Bill Duval and I will be your MC for today. I'm a Technical Engagement Officer in the Education and Engagement team here at the QBCC.
And my name is Heath Bussell. I'm a Building Inspector with the QBCC Cairns Regional Service Centre. I'll be back later during the first presentation and to host a Q&A session at the end of today's webinar.
Thanks, Heath. Today's session will be delivered in two parts. Firstly, a QBCC presentation on Are You Ready for Storm Season that will outline some measures you can take before and after a storm event and some useful links to other organisations that may be able to provide information and assistance. For the second part of our webinar today, our guest speaker is Dr. David Henderson from the James Cook University Cyclone Testing Station located in Townsville, who will be delivering a most informative presentation about the work he undertakes at the CTS. If you have any questions about either talk today, please send them through via the chat box down in the corner of your screen, which will look a little something like this. We will endeavour to answer as many of your questions during the Q&A segment at the end of the second presentation. This webinar will be recorded and will be available after the event. So if you want to pass on information to any mates or colleagues you think would benefit, we will be posting it up on the QBCC website for them to see. Your feedback is important to us, and we ask that you take the time to fill out the quick survey at the end of today's webinar. Your feedback is valuable, and we look forward to reviewing that, which helps us plan our future events. So please, get yourself comfortable, and we hope you enjoy today's webinar. It pays to plan ahead. If the weather in Queensland has taught us anything, it is that it can be as unpredictable as it can be severe. In recent times, we've seen flooding in Townsville, cyclones in North Queensland, hail the size of a cricket ball smashing homes in Brisbane, and the awful bushfires to kick off 2020. As builders, we not only construct buildings to hopefully withstand these forces of nature, but also have the responsibility to manage these adverse events during construction as well. Nature rarely affords us the choosing of the time of a natural disaster, but quite often we get time to prepare, and the more organised we are and pre-planning has been done, the more likely your business will flourish once again when the blue sky reappears. There are many ways in which a site can be managed, and we will try and go through what we think are the more common items to be managed, but I'm sure you will also think of many more. Being prepared before the storm should go a long way to aid the recovery once the storm has passed. Preparing your site. You may be in the unfortunate position that a natural disaster strikes during one of your builds, and I'm sure in North Queensland this is a matter of when it will happen rather than if. As a builder or principal contractor, it is your responsibility for the management of the site, and accordingly this will include the preparation of the site in the event of a storm. Building sites can be dangerous places at the best of times, and a good site management and housekeeping is something that all builders should aspire. Not only does this make it a more pleasant place for your trades to work, it is generally safer and may avoid any costly penalties should there be a workplace incident. I'm sure a lot of these points may seem like common sense, but good habits should be part of your daily routine. Should an unexpected weather event arise, you can respond more quickly and hopefully minimise damage, avoiding additional material and costly time delays. For any business, another costly and sometimes overlooked damage that can occur is that to your reputation, which may not impact the work you currently have in your books, but may be felt sometime in the future. So it pays to be prepared. In the event of an insurance claim, if your site has been poorly maintained, this may lead to premium increases in the future. So if you can demonstrate you have taken as many steps as possible to lessen the impact, it may lead to a more favourable discussion next time your premium is due. It may not be immediately obvious, but it pays to be familiar with the location of your building site. Adverse weather such as heavy rain and overland flow or storm surge associated with low pressure systems during cyclones can present conditions that would be considered out of the ordinary for your location. It may also pay to check the storm cover insurance in any hire agreements for plant or equipment you may still have on site. Wherever possible, isolate or disconnect services that feed into your site. Disconnection should help minimise any live hazards that may exist when you return. If part of the building was to fail or collapse during a storm and cut or rupture any connected service, having them de-energised can also help to avoid damage to the service provider's main infrastructure. Avoiding damage to any of the main infrastructure can help aid in the community recovery after a storm if time is not lost to re-establish essential services. Offsite preparation. Having a checklist in a time of crisis will allow you to systematically deal with issues and prioritise what needs to be done first. The checklist will also allow you to allocate items to specific people, and you will be less likely to miss an important task. Having thorough checklists will help aid you in pre-planning and also in recovery. Sometimes it can be quite difficult to obtain necessities in the time of a pending natural disaster. Panic buying can clear shop shelves in a matter of hours. So here are some typical items, if checked regularly, will help keep you prepared in the case of an emergency. Part of your plan should also include a review of all your business insurances to ensure they're up to date and reflect the true value of your business. It would be wise to check the current value of any plant and equipment, and if your insurance also covers any equipment that may be on hire. Don't forget, your staff could be anxious and have to make emergency plans to secure their own family and property. So make sure you have contingencies in place and there is time for everyone to be safe. Fuel for plant and equipment can become scarce in the days or weeks after a natural disaster. So filling up your vehicles and having some in reserve should be included in your plan. In times of emergency, you may be asked to help others if you have essential equipment. So having some in reserve would be a good idea. I'd like to now hand the presentation over to Heath in Cairns.
Thank you, Bill. Okay, building work and site wind classification. Even in non-cyclonic regions, sites may be subject to very high wind loads based on a combination of factors. With most construction work generally specified in relation to a site wind classification, it's very important that this is correctly determined prior to commencement. For new work, such as homes, sheds, commercial buildings, wind classification is typically already determined by a professional such as an engineer or building designer, and should be detailed on the approved plans, Form 15, or approval documentation. For renovations, smaller additions and re-roofs, there may not necessarily be an engineer or designer attached to the works. Wind classification can still be determined using Australian standards such as AS 4055 or 1170.2, or discuss with your regular engineer or certifier. There's also a number of helpful online tools and videos available, for example on the Cyclone Testing Station webpage. Once site wind classification is determined, construction work can progress as per the approved plans, the National Construction Code, and any applicable Australian standards such as 1684 for timber frame construction, AS 4440 for roof truss installation, and the NAsh standard for lightweight steel construction. Manufacturers' guidelines can also be relied upon, for appropriate installation detailing for various wind classifications. When utilising these guidelines, ensure systems aren't mixed or mismatched unless explicitly approved so by the manufacturer. There's also a number of industry bodies, associations and organisations such as the Australian Glass and Window Association, Timber Queensland, Wood Solutions and the Australian Roof Tile Association that have comprehensive and often free industry resources covering things like best practice, compliance, installation tips and industry updates. Generally, as wind classification increases, so too does the strength and robustness requirements of our construction work. When working in higher wind regions, you might see claddings required to be thicker, changes to framing and fixing detailing, or increased reinforcing requirements. When we're looking at roof construction for housing, it's important to have an understanding of the different pressure zones to a roof as identified in Australian Standard 4055. The areas subject to the greatest wind pressures are the roof corners, followed by the roof edges at the ridge, eaves gutter end, hips and gable ends. These areas typically require more stringent construction detailing such as closer batten centres or the use of cyclone assemblies in metal roofing and the installation of additional mechanical fixings to roof tiles, just to name a few. Similarly, when we're looking at external wall construction for housing, it's important to understand that the corners of our buildings are also subject to the greatest wind pressures. This can equate to more robust construction detailing to elements within these corner zones, such as claddings, linings, and the associated framing supports, and things like windows and doors, even when only part of the opening falls within a corner zone. When in doubt, check with the manufacturer and your certifier. Returning to site after a weather event. Before returning to site, make sure you keep up to date with the reports from emergency services and the local media. Ensure that you send suitably qualified staff to assess the site for damage, and maybe not the first-year apprentice. Preferably send staff with a buddy, just in case. After a storm or weather event, be aware that many hazards may exist, and having a plan or checklist may greatly assist in re-establishing the site. You might come across new hazards that not previously exist, for instance, structural damage to the building under construction, or items deposited on the site from other areas. Quite often in natural disasters, significant damage is sustained to service provider infrastructure and assets, and there can be long delays associated with these services being returned to their normal working order. When the time comes, you should only return to site once it is safe to do so. If you identify areas where damage has occurred or where dangerous substances may have been deposited, it may be necessary to safely barricade or secure off these areas until there is time to put a plan in place. Don't forget that native wildlife may be seeking shelter during a storm, so remain aware that you may have some additional and perhaps unwanted guests living on your site. Recommissioning of services may be necessary to identify any damage not immediately evident as part of the initial site check. Always ensure suitably qualified contractors are used when undertaking these recommissioning works. Foreign materials may have been deposited on the site during a storm, so be sure to have any suspect materials tested before they're moved. When you do eventually move or dispose of site debris, ensure you use appropriate personal protective equipment. Please be aware that there's been some recent changes to legislation relating to occupational plumbing licensing. Refer to the QBCC website for further details. Not all hazards encountered will be immediately visible. In fact, some may be invisible. Solar panels, for example, may be supplying power back into the electrical boards, even though the mains power may be disconnected. Ensure these systems are checked by a qualified electrician as part of your site check. And now I hand you back over to Bill.
Yeah, thanks, Heath. So resuming work. There's no need to wait for a storm. You can register your business with the QBCC Find a Local Contractor page now, which can be a useful tool to promote your business and puts owners in contact with trades who work in the local area. Natural disaster repair contracts are also available on the QBCC website, which can only be used for repair work and not the construction of a whole new dwelling. More information regarding disaster recovery for licensees is available on the QBCC website. You can also register your details on a disaster recovery rebuild register when a natural disaster occurs, which is a separate register that is established for licensees interested in working in disaster hit areas as part of a recovery. You may be returning to work on an existing site or contacted by an owner as part of the reconstruction process and need to be aware that new hazards may now exist at the location. Older buildings constructed with asbestos-containing materials may have suffered damage during a storm, and precautions need to be taken even if minor or emergency works are undertaken on the building and should be cleaned up and removed before undertaking further reconstruction work. Similarly, if there is any damage to other infrastructure, such as power, communications, water or gas, contact the appropriate authority or engage suitably qualified trades to check the services before continuing. So where can I go for more information? More information regarding storm preparation recovery can be found by researching the organisations that we have listed here. The QBCC website has a wealth of information or will provide links to other useful organisations. You may already be familiar with the TV commercials featuring Jonathan Thurston as part of the Get Ready Queensland Storm Season campaign, and a number of others provided by other authorities or some of the insurance companies. Some of these sites also provide useful planning tools to help choose more resilient building methods and materials to help resist or minimise damage from a natural disaster. So here are some useful links. The first on the page is a link to the QBCC storm season campaign. The next two after that are the occupational plumbing licensing for reference that we mentioned earlier. The fourth one on the list is the Get Ready Queensland campaign, which is by the Queensland Reconstruction Authority. Energex obviously for any issues or safety around power lines, Asbestos Safety Queensland for the management and handling of asbestos, and of course our feature speaker today, the James Cook University education site. So that's the end of the first presentation for today. So thank you for your attendance. We'll now move on to the second part of today's storm season webinar. We're fortunate to have Dr. David Henderson from the James Cook University Cyclone Testing Station here with us today. He is the Senior Research Engineer at the Cyclone Testing Station, and during his 28 years at the CTS, he's broken everything from screws through to complete houses. He's also conducted cyclone, thunderstorm and tornado damage surveys in Australia and overseas, and he's on the Australian Standards Committee for wind loads for housing and metal cladding. Many of you may not be familiar with the work that is undertaken at the CTS, and David will today give you an insight into the work that he does and what he gets to see when investigating the before and after effects of severe weather events. So without any further ado, I would now like to hand over to David Henderson.
Thanks, Bill. Welcome, everyone. I just need to move myself away so I can see the PowerPoint. There we go. So as Bill mentioned, we're going to have a quick history lesson on wind damage, and we're going to focus a little bit on the CTS, but really try to drive a lot of the examples that we've seen from damage investigations and see where that leads us into changes in current standards, and a little bit about some construction issues that we've come across again in either current construction or wind-driven debris, wind damage, sorry, wind-driven debris being one of them. So I'm sure everyone's fully aware that Cyclone Tracy caused massive amounts of damage when it went through Darwin, to 70 to 90% of housing being destroyed in the path of the storm. However, engineered structures did perform better than the housing. Similarly for Hurricane Andrew, 20 years later, that you had this massive event come through and took out 63,000 homes. Both of those resulted in massive changes to home building standards in both countries. What is it with the houses? Well, the houses are a common but complex machine, if you like. There's been from a traditional process that's evolved from holding the roof up, not trying it down into the ground as the wind's trying to pick it up and shake it about. I mean, there's many elements in a house. It's you got your top plate, your multiple ribbon plates, your rafters, your ceiling joists, king posts, queen posts, collar ties, lintels, all of these things, and they're all different in terms of their load sharing, how the load transfers through the house. Whereas a portal frame structure, a shed or a major commercial building is so much simpler in terms of its beams and rafters design. Housing is very complex in that, and yet we've got to get the load path as that wind's trying to pick the house through, with the roofing attached to the battens attached to the rafters, etc., or trusses all the way down. So wrist bone connected to elbow bone, shoulder bone, all the way down to ground level. So it's that load path that we've really got to pay attention to in our design and construction of our homes, and that leads us to that. Our homes, it's generally where we shelter, so they have to be secure. In terms of our understanding of homes, and it's the Cyclone Testing Station, like other organisations, really digging into these complex little structures, our housing. So, as Bill mentioned, we've looked at testing everything from roofing screws, batten screws, all those types of things, right up to loading up full-size houses and applying loads across the roof structure and pulling on the walls and seeing how the houses perform. And also in that, we've got boundary low wind tunnel, like other places, in terms of when you push the very turbulent wind across there, you're looking at how the pressures interact across the roof and the walls and all these different loading combinations across there. But all of that predisposes that we know what the wind is or what we're designing for in the wind. So in terms of the NCC, the National Construction Code, we have the country divided up into several regions, Region A, B, C, and D, whereas in Region B in Brisbane, we've got the 57 meters per second, where the Region C, that where Townsville, Cairns, and Mackay, the cyclonic region, we're looking at 70 meters per second for design. Now that's set at a minimum design criteria. So the NCC puts out a minimum acceptable design standard. So we're basically building to the bare minimum, if you like. And those wind speeds that I was saying is for the same risk level across the country in terms of a class 2. So typically seen as our housing and normal type construction, which for a 1 in 500 annual probability of exceedance translates to roughly 10% chance in 50 years that that design speed will be exceeded. So that's what we're designing for and a minimum criteria. Something to be on the lookout for is that within the latest public comment version of the wind loading standard, AS 1170.2, that Region B for Brisbane is being extended. This is apparently to take into account a lot more of the storm effects, looking at all the anemometer records around that region. So the people involved in that standard have been put through that expansion of Region B in that area. So in terms of the wind loads over the house, we've got the wind rushing into that windward wall, going up over the roof and around the back of the house. That means we've got that positive pressure pushing on the windward wall, lifting up the roof, trying to pick the whole roof up by its roof cladding and pulling on the leeward wall. Now, if we have a breach in our building envelope, like a broken window or a broken door, that positive pressure instantaneously enters into the building space, potentially doubling the load on the structure. Now, in regions C and D, cyclonic regions C and D, within the wind loading standard for housing, AS 4055, this is the assumed case. It's not necessarily how houses may be designed in non-cyclonic regions. There's commentary coming into the latest version of AS 455 that should hopefully clear that up for a lot of people though. So look, we're going to take some examples out from different damage surveys that we've done. So with the big one obviously recently was when Tropical Cyclone Debbie came through in the Whitsunday area. Very, very scary event coming down through there. I mean, you can see there on those timestamps how it just sat and hovered around the Hamilton Island Airlie Beach area. So not just these really severe winds, but the duration of them and the driving rain for that whole length of time as this cyclone is just moving around very slowly across the coast. So the question is, you know, why do we do damage surveys? What's there for it? Well, it's basically we're looking to see what did bad and what did good, looking at the good performance and the bad performance. But also crucially, it's really looking to see, was the design standard appropriate? You know, was the wind speed exceeded? In terms of, was this gone beyond that minimum design criteria? Was it the correct use of the design criteria, using the right materials put together in the right way? So again, it's a matter of not just looking at the broken stuff, but also looking at the stuff that performed well. So we focused on the coast in this example, and really trying to get an idea of the wind speeds across those impact zones. So we obviously highly rely on the Met Bureau's anemometer stations across the region, their official 10-meter tall towers in flat open terrain, typically at airports. And also we've got smaller towers that we drive out, we set up, we run away, we let them record the data for us, and that's basically at house height, and then we have them scattered with the permission of the councils. We've got them scattered through the towns that are in the impact zones to get wind speeds across there. So from those measurements, other measurements that were there as well, we can try to get a guesstimate of the design wind speeds across the region, which is really important to try to relate back to the aspects of damage and the aspects of how the building codes performed with it and in the construction. So as we can see, like we've got, you know, the extreme winds coming through Hamilton Island, Airlie Beach area, down through Proserpine, which is around 70 to 80% of the design wind speed, and then really dropping right off to less than 50% down Mackay to the south of the track, and less than 50% up at Home Hill and to the north of the track. And you can see how wide the footprint of the cyclone is coming through. Again, a very massive, scary event coming through. You know, a couple of 100 kilometers wide footprint, but remembering that the main peak wind speeds are near the center of the core for it. So let's going to jump down into Proserpine then. So work very closely and thankful for the data from, you know, QFES, Fire and Emergency Services and Fire and Rescue New South Wales, as they're going around doing their rapid damage survey, looking at what they can see from the street in terms of what's needed, tarps or whatever else except might be for their houses. And so the majority of the town there is green. So no real major issues for the majority of housing. If we strip those green dots away, we can see though there's a lot of minor, moderate, and severe damage across the town. And a lot of that damage, the severe damage, was associated with older housing. So housing built before those big changes came in the early 80s. So you can see that a lot of roof missing with the roof with the battens attached. The image in that top center line, you can see the existing old timber batten with the original 2 nails punched into the rafter. The cladding down in the lower left corner it did its job well. New cladding, screwed to the old battens. The cladding remained attached to the battens. No worries, it was just the battens that let go from the rafters. The retrofitting of that new screw roofing down to the battens stopped there. There was no strapping or no batten screws, or then from the batten to the rafter connection, or from the rafter to top plate and rafter to collar tie and all those other things to strengthen up that roof structure, to improve its connections to the wall area. And it's not just in cyclones that this happens. From the 2014 Brisbane thunderstorm event that went through, again, similar types of failure modes, new roofing put on older construction without the thought of the retrofitting going deeper into the structure. The image on the left, again, you can see the old batten sitting there with only a single nail this time, where should have been holding it to the rafter. Again, that should have had a batten screw, framing anchor, or strap, or whatever, to really improve that connection for it. Similarly, on the right-hand side of the photo, again, new roofing to older battens, and that larger chunk of roofing was an attachment or an addition they did to the property that obviously wasn't tied down very well at all. Now, there's a lot of, as Bill mentioned, there is a lot of information out there. QBCC has a great sort of checklists for rebuilding. There's webinars and stuff for builders and for homeowners on the Cyclone Testing Station's web pages. And there is an existing Australian handbook for upgrading structural performance of existing homes, both cyclonic and non-cyclonic homes. All right, so even we're looking at the wind speeds. What else can go wrong? One of the things we do come across is poor maintenance. Now, these are pretty extreme examples of corrosion for the roof cladding and screws, rot in the timber, and termite damage across the framing. And of course, obviously, you think, well, if that's in your place, you'd be doing something about it well before the event happened. But it may not be as obvious or in your face with it. So here's a hotel motel on the Bruce Highway. That is, we're doing our street surveys, looking at for damage for after Cyclone Debbie. We got permission to come on site, and it was quite important to us because we actually did an inspection on this place after Cyclone Yului several years before Cyclone Debbie, where the place lost its roof during that event. So coming to see a new roof that's been taken off during this event, and remember, these wind speeds are about 70% less than 70% of the design value. So technically, we shouldn't be seeing any failures of modern construction or new products. So we're thinking, well, what's wrong with the roof cladding? You know, we help write the standards. We do the product testing at the station. Now, is those way that we test? Is that correct? So in crawling over the property, it soon became obvious, no, the roofing was fine. It was still attached to its clips and to the purlins. It's just that the larger rafters and framing system for the carport had let go. And where it had let go was right down at the footing. The post had completely rusted through. And so when the wind lift came up, it picked up the whole veranda and just peeled it back over the hotel units. Now, remember, this place was re-roofed only several years before Cyclone Debbie. So this had already started happening, this corrosion there, and it just wasn't picked out during that time when they were doing that rebuild. So again, the weak link let the whole thing down. Okay, but for the people that know, you're going to tell me, bro, Proserpine's an old town. And it is an old town. So there is a very high percentage of old housing in Proserpine. So if we go over to Cannon Vale and the beach, it was on the coast, we came across examples of severe damage as well to modern construction, and a lot of examples of moderate damage. Now, some of those red dots on there are to do with some flash flooding that went through in some of those steep areas. But there were examples on Airlie Beach and Chute Harbour and Hamilton Island of severe structural damage to modern construction, you know, after that 1980 watershed moment that came through. Now, a lot of those types of damage that we're looking at were to do with places that had a great view, that were exposed sites. So obviously, if you've got a great view, you got the chance of a lot more wind coming at you, and you get design according. So in ASNZS 1170.2, the wind loading standard, there's a lot of factors that if you're on the side of the hill, you've got a great view, that you design for much higher wind loads. Similarly for AS 4055 wind loads for housing, you might, instead of being down amongst the suburbs surrounded by houses with no view, which could be a C1, you're up, you got a view, you could be C2, C3, and C4, or even beyond the scope of AS 4055 and have to use 1170.2. So just on 4055 and issues with interpretation of that standard through in its recent public draft that came out for comment, there was a whole heap of changes made to aspects, especially in terms of topography, to really try to streamline it and make it a lot more straightforward in terms of working out the slope of the site for where your house is, and then working out the site classification for that location. And a lot more definitions for the top of the hill and the bottom of the hill. So do yourselves a favor, get a look at the public draft of when the new standard comes out and make sure you're familiar with those changes to it. So just on the topography and things with great view, we're back on Hamilton Island, and you can see there was a massive amount of wind load coming at this place. You can see how the trees are completely stripped bare, lots of broken branches, everything else. So a heap of wind coming here. What we're looking at on the left-hand side of the image is that little bit of galv steel is the bracket that was holding the veranda beam with the roofing screwed to it to the top of that veranda post that you can see on the right-hand photo. Now you've got a length of about 20 big roofing screws, your tech screws type 14 gauge, holding down your cladding to that steel RHS veranda purlin. But it all ended up in about 4 pop rivets in that bracket. Now that went through the design stage, through the building stage, through an inspection stage, and yet that simple math of adding up all those big honking screws and ending up with only 4 little rivets wasn't done. So it's a matter of all that wind load gets concentrated. So you've got to have bigger fixings, not smaller ones. The fact that this let go on this and several other units also meant that as the veranda peeled back, it took parts of the house with it, or the units with it, and then opened up the whole building to more water and damage, and basically totaled all of those ones as well. And it wasn't just major stuff like that. There was a lot of other minor damage that resulted in a lot of major internal damage with things. So cladding peeling off, gable ends, soffit linings, brick skins for not having enough brick ties or other aspects to it like that, all letting down the performance of our monitored engineered structures. So these minor details not being carried through basically wrecked the building to try to do its function after the event. Really impacts on this community's recovery. And so a case in point is our simple bit of bent metal called flashings that, trying to cover up the gaps between the roofing and the walls. So these little bits of bent tin getting peeled back causes a fair bit of grief to the inside of the structures. So in using damage survey data and getting access to claims data, working with insurers, that we're able to work out that examples of this can cost about $1,000 per meter to repair, especially if it's on units, strata property buildings, that type of thing, where the water comes in, goes through several floors and several units, causing a great deal of loss. So with using that cost benefit work and finding and documenting so many of these types of failures, we're able to get changes through AS 1562.1, the cladding standard, so that there's now a minimum thickness required for the flashings and a minimum fastener spacing and type of fasteners used. So no longer can you use pop rivets and aspects. You've got to use real screws, and they've got to be fixing to something real underneath the cladding. So if you're not aware of it, please get a copy of 1560.1 and have a dig through that. Similarly, this one's an example from TC Marshall. These very modern high-rise buildings in the centre of Rockhampton had wind speeds less than 50% of design come through. And yet you've got, you can see cladding hanging over the edge of the building. You've got loss of soffits from very high up, also adding to the debris field as it gets strewn across the town. If we go up to the roof of the place, we can see the aircon's been knocked over, the vent systems, the flashings on that skillet roof peeled back, taking the roof cladding with it, causing a great deal of damage. So again, in AS 1562.1, we've now got minimum requirements for fixings of attachments that are on the roof structure. So not just fixing to the roofing, but down fixing to purlins or other types of substantial support to look at that. And then we get on to other things, what happens if they do fall off your building. So there's wind-driven debris. It happens in thunderstorms, it happens in cyclones. The wind picks up stuff, whether it be from the building or from what's lying around in the yard, and hurls it at other things. So we've got bits of timber from older housing get thrown through other points, damage that's right down to complete sheds that have no poor footing details getting picked up and dragged through other housing to it. There is a test that we can do. It's an Australian standard test. Yes, it is a fun test to do. We basically take a 4 kilogram piece of timber and hurl it at unsuspecting building products. And within that, it's got a speed of in excess of 28 meters per second or 100 kilometers per hour as being a fraction of the wind speed that's happening at that time. Now, in terms of what we're looking at, you're trying to have a protect your building envelope. So it may be in terms of a life safety issue for a cyclone shelter, that there is a wind-driven debris test, but other times it's trying to protect that the door or cladding or window screen or whatever it might be doesn't get broken and doesn't let the pressure enter into the building space. But it's not a matter of just hitting in the center of something, because that may give a lot of deformation as that missile hits. The product, or in terms of the roller door, might be able to give and absorb that energy. But if you hit right next to the edge of it, it's a different matter. It's a real cutting action. So just don't hit in the center. You've got to look at other aspects of to get through to make sure the product passes. Here's a case after Cyclone Van. It's a really great window screen set well off from the window, so when it gets whacked by something and deforms, it doesn't break the window behind it. Trouble is, the front door blew in. That pressurized the building space, popped out the end wall, popped off the roof, causing a great deal of damage to it. So we've seen that time and time and again after many other cyclones, in that you've got doors that get let down. Now, whether there's not enough, too much area, surface area, and not enough meat in the drop bolts or the locks, or they're using hollow core doors that with the lock set, you're not left any meat left, and it just smashes through, the pressure pushes on it. So in terms of, it's really a matter of looking at how to get that building envelope that to remain intact. So if you've got a door entrance opening inwards like this, it's a matter of having a good quality lock, try to keep away from hollow core doors and not much meat in them, and using drop bolts as well, just to spread that load out. So you've got a couple of hinges, not just a center point, but maybe a drop bolt as well to spread the load out across the frame. Similarly for windows, issues with poor fixings of windows in times of frame, both old and new construction. And there is a lot of work out there. I mean, the AGWA produces some great guides in how to design and fix in windows into house framing. So have a look at their website on that one. A lot of the manufacturers are putting fixing details stuck to the window when they get delivered to site. These are photos taking off the information that was, in the center of the window, showing the minimum required fixings, the packing, the type of size of nail, etc. for that one. However, yet again, we find a lot of issues where it's just the framing or finishing nails that are using to hold the frame in, and then covered up with the architraves. So not even any packing in many examples with it. So again, we've really got to make sure we've got the right products designed for the right place and followed through in terms of the installation instructions. A lot of these openings can lead to water coming in, whether it be the wind and rain getting pushed up the valley gutter, up over, or the cladding being pushed up, the water being pushed up the cladding underneath the ridge capping, dropping down in the ceiling, soaking the ceilings insulation, dropping the ceilings down as well. And again, we see this after many cyclones and some thunderstorms as well. But it leads to so much extensive damage to the interiors, potential corrosion, mold, all those things, and it takes a complete refit to fix the property afterwards with it. But we don't actually need a hole a broken window or a door to let the water in. So, oops, my apologies. I got to click here for now. So, and this is an example that we've got the video running. That yes, as the homeowner points back to the window, you're going to see a whole heap of water gushing through the slider there. It's also coming under the sealed end as well. Obviously, he's paying good attention to safety to keep away from windows, and there's just rain coming down through that ceiling there. What you can't see is that this is a two-story house. and that water is coming through the balcony door on the top floor as well, then coming down through the floor and down through the aircon ducts through there into the house. So you've got so much water coming in during these severe wind events. And from a lot of our surveys that we've done across the different cyclone events, you're getting water coming into over 70% of properties have some form of water ingress. Now, whether it's coming in through the roof, through poor flashings or ridge cappings, or whatever it might be, box guttering systems that don't have sufficient overflows, coming in through under our doors, through our windows, but it's coming in through all these different places. Some of it can just be mopped up without much distress afterwards. Generally, there's a fair bit of stress to the homeowner at the time, but a lot of it does cause so much damage that has to be repaired afterwards, and to the extent that people may not even be able to live in their house after the event. So why is this? Why are we getting so much water coming through these different things? Well, in terms of windows and doors, especially the glass windows, there is actually an Australian standard test. But it's a very low pressure that you're looking at for it. So it's even well below serviceability design that these pressures are there. So even for our cyclonic conditions that we've got, 200 pascals, whereas the design pressure might have been up around 2.5, 3 kPa, 3,000 pascals for it. So it's no wonder we're getting water coming in around about 30 meters per second, so much below design on it. So we've been having working with AGWA to look at this and kind of look at what type of ways we can try to get this across to homeowners and other ones around there, developers, and they have maybe different levels of performance. Really at the early stages, a long way to go yet, but if we can come up with different maybe performance standards that different criteria can meet as a voluntary system, so people may know that if they what best to look at for their situation for it. So it leads us into other products. So a lot of we hear it that, that test standards have a factor of safety to count for errors in construction, it's just rubbish, it's false. Test standards are actually based on fabricated to manufacturer specifications. So it's to best practice. So if we've got design or build errors, the building is far more vulnerable and not able to withstand the design loads. So some cases in point, we've got strap, and this is taken from all over the place, these photos. So from one of our surveys we did around the Brisbane area, here's some tie down strap for truss to the top plate. You can see there that one of the legs on the strap, that the nails have missed the holes for the framing anchor, and with all of that stuff coming through, it's almost like a tear line now. Not only do you have the pre-punched holes, but you've got the new holes drilled in by the nails running through. So you've greatly weakened that strap, and it's not bent even around the plate as well. Framing anchors, again, you've got the one on the left, one of the nails missed the framing anchor completely, so it's down from 4 to 3 nails, and those 3 nails aren't in the right places either. On the one on the right, there's actually more nails than required, but with having such a grouping like that, you basically splintered all that area underneath those gun nails to, again, greatly weaken any hold down that framing anchor may have had to it. This one from Townsville, some housing we were looking at, and again, the great screws every second crest of the corrugated. Unfortunately, they all missed the batten below them, and in the bracing for the plywood bracing panels, all the nails were overdriven. So then over half the way through the plywood, the nails were thumped in. So again, hardly any capacity of that bracing panel left because of that over nailing. And the manufacturer's details that the nail is slightly proud, of the plywood. So having the gun nail set so hard to go through, it's basically destroyed any capacity that bracing element may have had. Metal battens, pretty good stuff, but not when they're fixed like this. So the screws have to be down flat against the foot of the batten. If they're on an angle like this, or they come down and score the web of the leg of the batten, they greatly weaken the capacity of the system as well. So they partly cut into it. If your head of the screw is on an angle, as the wind uplift is trying to pull up the batten, that head of the screw will cut into the foot. Similarly for roof cladding, if you don't have that screw perpendicular to the crest or the rib, if it's on an angle, you've got that all the load is bearing on one edge, and it'll basically cut through that cladding pretty quick. So again, greatly reduces the capacity of the product. Here's an example after Cyclone Yazi, with this set of units here. You can see that main rafter picking up all the load from the purlins, from the cladding coming through, and it's held in with expanding anchors at the top of that, reinforced masonry blockwork lintel. So again, with those expanded anchor and the forces trying to drive through, when you expand the anchor, you got all those pressure forces going out. There is no edge distance here. So again, I can't, just completely against what any criteria would be for the design of that. So again, all our test data and regulations are not much use if they're not used. So product manufacturers need to provide and promote installation guides to designers and builders photos, and we've all got to use them and practice to make sure that the products all end up to be as strong as they need to be. So to conclude, the wind finds the weakest link. Failure of a single element can lead to the progressive failure of the structure, and continued education awareness of the whole community. So that's builders, regulators, manufacturers, and owners is required, especially in the owners in terms of the maintenance of the structure well after building is finished. Thank you.
Thank you very much, David, for sharing your extensive industry knowledge and unique insights with us this afternoon. A most informative presentation. We'll now move on to the Q&A portion of the afternoon. If you would like to submit a question, as mentioned earlier, please do so using the question box and send button on your webinar control panel. We'll try and answer as many questions as we can with our remaining time that we have allocated today. So during the presentations, we did have some questions come through. So look, I will start with what we do have currently. We have a question from Chris, and I believe it's for David. Through your damage surveys, have you found any interesting points with regard to roof-mounted PV arrays? For example, how these fare in high winds or any installation issues?
Yeah, okay. In terms of one of the things that we were focusing on our recent damage surveys, and this would be from, I guess, from Cyclone Yazi onwards, was to look at how solar panels or PV arrays have been performing. There is a testing for them. There is wind load design criteria for them in the wind loading standard. And the issues that we've seen in the lab in testing the panels is not generally so much the panel itself, but how the extruded bits of aluminium connect from the edge of the panel down to the rails, and then the rail down to the roof cladding. So with all that in mind, and with a lot of the testing and manufacturers and distributors using that over the many years, that we actually haven't seen too many panels lying on the road or the streets when we've been doing our damage survey. There has been occasional one or two, and generally it's been around those fixings of the actual rail or the panel themselves being too far apart and not to the, again, to the needed load on it. The other types of ones that we have seen issues with is when there's been an inclined panel mounted on a roof or a commercial building, and the framing behind it hasn't been designed for the wind load that's been there. So the whole inclined structure has been taken away and removed and put out on the street. But generally, and domestic parallel to the roof has been performing quite well. But again, you're making sure that the supplier of it, the installer, has the required test data or the compliance sheets to show that they have gone through that process and demonstrate that their product is wind rated.
Okay, thank you. We have a question from James. Based on your research, what do you see as the most common construction issue with buildings in high wind areas?
Okay, so there's a couple of things on that one. Let's talk about older stuff first. So and that doesn't necessarily mean pre-80s. It could be houses built since the 80s or the 90s. They're getting kind of middle age now, a bit like me, thin on top, very thick in the middle. Got problems with our joints. You know, it really needs to be looking at maintenance. And that's what we're really going to promote to the owners about our homes are big machines. They've got all these different working parts. We just don't want them going anywhere. So we're going to make sure everything's in good working order. So really to promote that maintenance on anything over 10 years old and inspections, ongoing inspections every few years, whether it be 5 or 6, 7 years, to make sure that things are in good order is one thing on that side of it. Other
Okay.
aspects in terms of, sorry, Heath, the other part in contemporary construction, so around good site classification, to making sure we got the right things around it, and things installed to manufacturers. Because again, you can go onto many sites and we'll see overdriving of nails for bracing, or we'll see roofing screws or things on an angle or batten screws around that. So it's just that attention to detail, because all of those components, there's not a lot of meat in them to get down, because we're all building to the minimum. So a good way is also to think about building to a wind level above. Sorry, Heath.
Thank you, David. Yep, thank you. We have a question from Nayan. It was mentioned in one of the slides that the garage doors can potentially contribute to high internal pressurization, and hence leading to failure. Is there any regulations to ensure that the garage doors are rated and tested to withstand before failing and offering an opening to the house? As mentioned, wind causes failure at the weakest link.
Thanks for the tough question, Naya. Okay, so in I think it was 2013, the garage door standard, or large opening door standard, whatever it's called, was modified so that large doors, like your roller doors, panel lift doors, that type of stuff, whether it be domestic or others, have to be designed if they're used in cyclonic conditions. So they have to be wind rated to take the wind either pushing on it or sucking on the thing to pull it out of its opening, which generally means they need good wind locks, engaging the door into the tracks, and those tracks have to be well secured to the frame of the building, and that part of that frame well secured to the rest of the building because of the catenary action acting on that when the wind's pushing or pulling on it. However, in non-cyclonic areas, that change I don't believe is coming through. But as you pointed out, Nyan, that if that garage door fails in a non-cyclonic area, it does pressurize the inside of the building with that wind pushing on it, as we saw in that diagram. So yes, I mean, there are products out there and looking at that you can get wind rated stuff for it. If you're not having wind rated products on your building or your house, you've got to design for that in full internal pressure. Thanks, Heath.
Thank you. Thanks, David. Question from Darren. Does David have a view on the decline in cyclone activity in southeast Queensland and predictions for the future?
Oh, thankfully I'm not a meteorologist or a climatologist or any of those ologists. I just break stuff, so I don't have that. But we're talking about very extreme events that are thankfully very rare. So I think it's very, very dangerous to say anything about a decline. Look, and I really can't comment down here, but I do know like Cyclone Dinah was a pretty scary event that happened in the late 60s, and there was a couple in the 50s or something that, that caused a lot of grief. But and again, I don't have too much knowledge of the activity in this area, but up north where you go through cycles of it. So in the 70s, there was a higher frequency of it, then it lulled down. Now, again, I'm not on the meteorology side, but with all the different factors, whether it be El Nino, La Nina, or the Southern Oscillation Index, or the Madden-Julian Oscillation, or the one that comes across from Africa, all coming together to give you these big, decadal type cycles as well. So yeah, I don't think you should be saying anything about decrease, if only in the short term. Things will come back to bite.
Thanks, David. We have one from Claire. You speak about windows leaking at certain pressures, for example, 200 pascals. What wind speed in kilometers per hour would this equate to? And do we experience these type of winds in non-cyclonic events like thunderstorms?
Yes, those wind speeds do happen. I think from memory, 200 pascals, and here we go. I don't have a calculator with me. I'm terrible with math on the spot. Bugger. Look, as a rough guess, I think we're looking at about 25 to 30 meters per second, those types of wind speeds. And that was for like, I think from memory, a C2 type criteria. So being in an N region is even going to be less than that. So yeah, and look, in terms of damage stories, and we're doing thunderstorm surveys and stuff down around the Brisbane area or northern New South Wales, yes, we've seen water and stuff come through there. Also on medium rise strata type buildings where you've got wind driven rain coming through those balconies and stuff like that as well. So yes, it does happen in non-cyclonic areas as well.
Okay, we might have time for one last question. We've got from Michael. With focus on the wind rating in regions A and B, should the framing standard for region A and B be changed to include dominant openings? For example, if Mr. Homeowner races out to save his garden furniture or the car, will he put his home at risk? So I think referring to, pressurization of buildings and any openings.
You would kind of hope that the homeowner's not racing around in the middle of a cyclone to save his garden furniture. He's done his prep well before then. The pressurization that we'll be talking about, for much higher wind speeds for that one. But look, having a protected building envelope is always a good thing with that, to make sure you've got a good rated building envelope for it. Because even in cyclonic regions, that if we're designing for a window to break, we still hope a window doesn't break. And like on my place, I've got storm shutters that I put on the building prior to the cyclone, turning up in the warning and watch zones, just because it helps reduce the water coming in. But if you can keep the building envelope intact and don't get that pressurization, well, you've got more safety up your sleeve.
Thanks, David. Look, unfortunately, that's all we have time for available as part of the Q&A today. Thank you to all of those who have submitted questions, and thank you, David, very much for your answers.
No worries.
Yeah, thanks, Heath. So we would like to extend our thanks to David Henderson and the James Cook University Cyclone Testing Station for their participation. And I'm sure you're able to take some very useful information away with you today. I'd also like to extend our thanks to my co-presenter, Heath, from the Cairns office for his input and assistance with today's presentation. QBCC would like to thank you for your attendance. And if you have any further questions about today's event, please send them through to us by logging into the My QBCC using the feedback tab, or go to QBCC's contact us on our webpage. Remember, you will receive the short survey after the webinar seeking your feedback. So please, if you can take the time to complete this survey, this will help us to continue to provide most informative events that we can for you. So thanks again, and thank you for participation, and everyone have a good night.
Good night.